In this video, I'm gonna be talking about another approach for event extraction, and we are using a generative approach, generative question answering approach, and I'm gonna be focusing on this paper in 2022. Event argument extraction has long been studied as a sequential prediction problem with extractive-based methods tackling each argument in isolation. Although recent work proposes generation-based methods to capture cross-argument dependency, they require generating and post-processing a complicated target sequence. So they post-process and generate a very complex template that we use in generative models. Motivated by these observations, recent pre-trained language models capabilities of learning from demonstrations, we propose a retrieval-augmented generative QA model for event-augmented extraction. It retrieves the most similar QA pair and augments it as prompt to the current example's context, then decodes the arguments as answers. And so it retrieves the most similar QA pairs as prompt. Finally, we propose a clustering-based sampling strategy and conduct a thorough analysis of how different strategies influence the few-shot learning performance. So this is a current test example context question for each role have great similarities to the retrieved demonstrations. You have context, for example, one of the difficult judges is nominated by Adam, and then for this current example, we retrieve demos from the training. But when searching through examples in the large store, in training set, we call it large store for demonstrations, any input-output pairs, the two most similar examples input-output pairs are presented. Both of the retrieved examples' contexts have large semantic similarities with the context of the current example. The first retrieved examples questions also match the input examples. The second examples questions do not. Thus, to help the model determine how much to learn from the demonstrations is also important. So we have event ontology, templates, and questions. We focus on extracting event arguments from a sequence of words. An event consists of a trigger and type of the event, corresponding arguments for event type. Both the event type and argument roles are predefined in the ontology. Apart from the event types and argument roles, the ontology also provides definition and templates for the argument role. For example, when we say this is our event, movement, transportation, evacuation, the template for the argument is provided. For example, say something transported something in argument 3 from argument place to argument 5 place. Based on the definitions of argument roles and the templates in the ontology, we can generate the natural questions for each argument based on the mechanism that is explained in this paper. For example, argument 1, which is a transporter, this one is transporter, we can say who is responsible for the transport. Or argument 2, we can say who is being transported, or anything, or the same. And when we say store, because this paper proposed to use in context demonstrations, input-output pairs, as prompt to test the zero-shot performance of large pre-trained language models. For our retrieval-augmented approach, we denote the set of demonstrations or prompts to choose from this store. So this is the architecture for any. First we retrieve, and then the rest of that is just a conditional decoder that generates the answer. And of course we have a binary thing. It's one or no, if you are using analogy or not. If you are using or not. BART is a large pre-trained encoder-decoder transformer architecture. Its pre-training objective is to reconstruct the original input sequence, and so it's a denoising autoencoder. Prior work reports that this objective helps the extraction problems. Thus we use the pre-trained BART as our model, because it's both encoder and decoder. It is presented in figure 2. So for each argument row, the model's input is conditioned on the current example context, question for the row, and the demonstration store. So the goal is to find the maximum conditional probability. The argmax of this probability of predicted argument sequence Y conditioned on X. So given an example for each argument row of the event type E, the input format, so we say sentence, then demonstration, and then question, then we give input context. That is the final input sequence. But question is from the question set derived from the respective ontology. For input context, we mark up the current example's trigger word with this token, trigger token, and for demonstration, we first retrieve it from demonstration store, which is the most similar to the question, current question, and input context. And so we use these token separation to have this demonstration, because this is question and this is your context. I have explained SBERT in playlist for contrastive learning and Siamese network by Mrs. Gorevich in Darmstadt, I think, and to calculate the similarity scores between the current instance and all demonstrations in store. So to construct the target sequence, we first determine how much to learn from the demonstration. If the similarity score is above a threshold, and the demonstration and current instance both have a non-empty answer, then we assign 1 to analogy. So if the score is above a threshold, then we call analogy is yes. Otherwise, analogy is 0, and we have a loss for that. Then we minimize the joint loss function during training. And this one is the cross-entropy loss between decoder's output and the target sequence. And as I said, it's just analogy, it's just a binary cross-entropy. So at the test time, we conduct greedy decoding to obtain the target sequence, then we split the decoded sequence with respect to that sequence argument. So we propose a sampling method called joint encoder. It uses k-means clustering upon the embeddings for both input context and trigger text, because this is easier to implement as compared to the one-round active learning setting. So given some unlabeled examples, sample size n, then we obtain embedding for all unlabeled instances, and we then do clustering and we get the samples. As you see, for argument classification, the F1 score, of course precision and recall are important, but F1 score is still below 75. Even if we use the analogy you see the F1 score is still below 75. And this is for ACE 25 data. So you expect that for biomedical text is even worse, because that one is much more complex. So these are generated questions for argument roles in wiki event ontology. For example, if you have this complex event type, then you have these argument roles and these questions. What is being dismantled? Who is being dismantled? What is the instrument used in dismantle? So you can generate these questions.